Suppose a baker claims that his bread height is more than 15 centimeters on average. Several of his customers do not believe him. To persuade his customers that he is right, the baker decides to do a hypothesis test. All right, so we could actually set up the null and alternative hypothesis now. The baker claims that his bread is more than 15 centimeters. You want to put what you actually want to prove as the alternative hypothesis. And here it's not a p, it's a mu, because we're talking about the average height of his bread, right? He said more than 15 centimeters on average. He thinks that the mu is more than 15. The reason we put this in the alternative is because this whole process will either prove that the null is rejected or not prove anything. And if the null is rejected, that means the alternative is true. Okay, this is why we want to place the thing we're trying to prove in the alternative hypothesis spot. All right, and then remember that the null is just the opposite of the alternative. So we filled in the alternative first. And then in the null, we say mu and 15, and we put either equals to, or we put less than or equal to. We just put something that contradicts that mu being greater than 15. Right, so that's us setting up these two just from reading what the baker is trying to convey, is trying to convince. That went in the alternative. The null was just a contradicting statement that actually the average is less than or equal to 15. All right, he bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters. So from that, we have a couple pieces of information. That's why I gave us the little note category here. We have a sample size of 10. All right. And we have the X bar, the mean height of this sample was 17. The baker knows from baking hundreds of loaves of bread that the standard deviation for the height is 0.05. All right, note here that it's not the standard deviation of these 10 loaves of bread. It's not a sample standard deviation. He's saying that based on this big historic data he has, essentially his population, this was the standard deviation. We have the population standard deviation here. It's 0.5 centimeters. Population standard deviation. All right, we're now going to use our online calculator to actually see what the p-value is. It's going to be our first time looking at these one of these examples. So we are going to go to number 14, hypothesis test for a mean with statistics. I don't think I have it. Yeah, I don't. That's okay. Let's go up to our LibreText statistics calculators. They're towards the top of our Canvas shell. LibreText statistics calculators, open in Safari. We're going to go down, we're going to find a hypothesis test for a mean. And I mentioned earlier with statistics or with data, if you have statistics, that's what we currently have here. You click on that. If you had data instead, so this just means that we had like a whole list of data, you're going to have just an option to put in all of the data with commas separating. Here we were given the sample size, we were given X bar. So we're going to go to a hypothesis test for a mean with statistics. All right, on the left, we have that sigma known and sigma unknown. Okay, again, that's because in the background, they determine if they're using a z-score or a t-score, if it's a normal distribution or a student's t distribution. We know what sigma is. We know the population standard deviation. So we want to click that one. All right, we want to put in 0.5 for that standard deviation. We had a sample mean of 17. We had a sample size of 10. Now, these other values here are going to be for the alternative hypothesis. This mu naught is 15 because in our alternative hypothesis, we had mu was greater than 15. So we put 15 here and we put greater than there. All right, again, these two values here, this one and the toggle down below, are from the alternative hypothesis. I click calculate. and I see that that p-value, so it's going to give me the z-score, and it's also going to give me the p-value. That p-value is 0. It's so small that it registered as 0. All right, so add notes from calculator. All right, I want you guys to write in. I'm not going to take the time to write it here because I just showed it, but add notes of what you put into your calculator. So when you look at this later, you're not confused. All right, P ended up being 0. This is as small as it can get. It often will not actually be 0. All right, there are on our future examples, you'll see what it is, and that's after we discuss what we're comparing it to. But 0 is as small as we can get, which means if the P is low, the null must go. This means that we can successfully reject H naught. And if we reject H naught, if we actually successfully reject H naught, then HA, our alternative hypothesis, must be true. This is the ideal situation. If you reject H naught, we have now proven our HA is true, and that's why we put what we want to prove in the alternative hypothesis. We wanted to show that the average height was more than 15 centimeters. So we put the mean being more than 15 in the HA, in the alternative hypothesis. And we successfully showed here that HA must be true since H naught was successfully rejected. So as our little summary from this test, we have sufficient evidence to support that the baker's height, average loaf, different ways to word it. We want to include the word average there somewhere because this was a population mean that we were running this test for. All right, we have enough evidence to support the baker's average loaf height is more than 15 centimeters. All right, you should be practicing writing summaries as we go through these. There's your first example of a summary in this chapter.